It's my pleasure today to welcome you to the Frontiers seminar and to welcome Dr. Ayanna Howard to Georgia Tech. Dr. Howard is the Dean of Engineering at The Ohio State University and the Monte Ahuja Endowed Dean's Chair. Previously, she was the Linda J. and Mark C. Smith Endowed Chair in Bioengineering and the Chair of the School of Interactive Computing at Georgia Tech. In addition, she serves on the board of directors for the Partnership on AI and Autodesk. Dr. Howard's research encompasses advancements in artificial intelligence, assistive technologies, and robotics, and has resulted in over 250 peer-reviewed publications. She's a fellow of IEEE, AAAI, and has won the Nico Haberman Award, the Richard A. Tapia Achievement Award, and the Nesby Janice Lumpkin Educator of the Year Award. She has been recognized as one of the 23 most powerful women engineers in the world by Business Insider and as one of the top 50 U.S. women in tech by Forbes. It is a pleasure again for me to introduce my friend, Dr. Ayanna Howard, and we're looking forward to your seminar today. Thank you.
Thank you, Sam. So I was going to say, before I was going to do this, I was going to just show a couple of images which I just did the Google search. And I really like the one which it said most companies, when they start designing technology, they don't think about accessibility until after the fact. So the attempt, and I was going to also say that I did have the Audible from Amazon. It's a great book. If you have not read it or heard it, it's a great book. You should really check this out from Ayanna Howard. And my niece, who is 16-year-old from India, called me because she saw this program on View. And she wanted to know whether I knew Ayanna Howard. So first time she felt I knew someone who is important. So that was great to see. So with that, Ayanna, it's all yours.
Thank you. Thank you. I am going to share my screen. Okay, so one of the things that I was asked to do was really talk more about future of the field. But of course, I'm always an academic, I'm always a roboticist. And so I did interweave some of my personal research as I'm talking about this future and the things that I think about with respect to artificial intelligence and robotics. And so I'm gonna walk you through the things that I've seen as I've been in this field and also as I continue thinking about the future. So one of the things right now, if you think about all the aspects that are out there, we have sensors. We have sensors that are littered throughout our world, whether it's on our city streets through cameras, whether it's embedded in our buildings through actual embedded sensors, whether it's wearables that we walk around, even including our smartphone, which has an amazing amount of sensors that is collecting information about not only us, but our environment and how we interact with that environment. And so if you think about what does this mean, it means that with all this data, with all of this information, we can use it to actually do things that are of value, that provide enhanced quality of education, healthcare, energy, water, all these aspects that will improve our quality of life, improve our society, is really driven by the fact that we have all this data. Now, one of the things though is that given we have all this data, how do we make intelligent decisions using that data? How do we filter through that? How do we extract those things that can enable us to really lean into the solutions of the world? And so when I look at AI and robotics and the role in the future, what we continue to see and the evolution is that the data's there collecting even more and more and more. And that when you have artificial intelligence, which is the algorithms, the processing power that makes insights based on that data, it's then fed into the robotics, which is the actuation. And the actuation could be virtual, so it could be a virtual agent that is still actuating, moving around, or it could be a physical. And so if you think about the coupling of AI and robotics, it really is this concept of processing information, making decisions, and then doing something in the world for us in that aspects. And my thinking and what I've seen is that society and the world embraces this because when we do it right, it actually provides better outcomes for us as a society, for individuals and things like that. So I'm going to talk you through my journey, because again, at the end of the day, I'm a researcher, but then position that in terms of what I see as his future. So one of the areas that I work in is in designing, developing both the robotic systems and the algorithms surrounding robotics, artificial intelligence to gauge children with special needs, um, primarily with motor disabilities and exercise. And so I just basically call it exercise, but the exercise is completed and done in conjunction with clinicians and therapists that are thinking through, that are the experts, they're the domain knowledge experts that we're trying to extract. And so what this does, and as I think about engineering and our role as engineers, I like to give this as an example because it shows the power of engineers and engineering when we are collaborating outside of our disciplines, when we're collaborating with domain experts in other areas and bringing them into the fold and creating solutions with them and for them, but really with them in order to really solve some of these societal challenges. And I think that's one is the power of engineering. I think that's also the power that we bring when we're educating the students of when you're designing these solutions, remember that you don't know everything. You are not the domain expert for the application necessarily. And so giving them the skills as engineers and educators to also think about how do you interact with those that are outside of the discipline in this seamless fashion. So a little bit of background in terms of children with special needs. And I always say this because a lot of times, sometimes uh, people don't realize that the numbers that are out there that are impacting our world. And so currently there's an estimated about 150 million children with disabilities worldwide in terms of diagnosed. As someone who works in this field, we always think that it's more. So places like the United States were actually pretty good at having parents basically either take their child, recognize we have the diagnosis, they basically claim these aspects because it's tied directly to services. Whereas in other countries, it's not so correlated. And so we think that the 150 million is an undercount because there's still some countries in this world where if you have a child with a special need, you don't claim it or you hide it or you don't admit it because it's not directly tied to services. And so we actually think 150 million is an undercount, but for the purposes of this conversation, we'll go with the 150 million. So being an engineer, computer scientist that's working in this field, the very first thing, and this deals with this aspect of the data and how do you understand and make decisions and design technologies around data. The first thing that we do in healthcare, and especially with when I'm working with children with special needs, is going into the field and collecting the data in the field. I think a lot of times as engineers, we like the labs, we like our own labs, and I say that we tend to sometimes do toy problems, right? We'll bring in grad students or undergrads, and we'll do our subject testing in the lab, and then we make claims based on that and say, oh, and it also applies to this target demographic or this application. And I'm of the fundamental belief that if we're designing solutions, we need to go out and use and collect the data from those environments. And it's going to be noisy and it's going to be crummy and it's going to be hard to actually figure out and filter. But when we do, we actually provide more value to the field and we provide more value to research because it then can be used for basically creating value for the world. And so in my group, we do a lot of this understanding of human-human interactions. We go in, we collect data based on cameras, based on wearables, looking at not only the interactions between humans, but also the interactions between humans and the environment, humans and objects, humans and robots. And what our goal is not to invent something like designing robots for intervention. Is not my role to say, well, I know what intervention looks like because I'm the robotic experts. It is, let me see what the domain experts call intervention, and let me figure out how do we then take that and transform it so that it works with robotic systems. And what that does is it, one, brings in these experts in the clinical space and the therapy healthcare space, but it also ensures that when we then deploy these AI systems or robotic systems into the real world, that it actually works. And the toy problems in our lab, they actually will work, even if we're thinking about pilots, because we're basing it on real human data. That could be very noisy. So the system that we've designed is basically gamification, gamified technology. And what that means is that we decided early on when we looked at these human-human interactions that it was not in our best interest to design a robot that could manipulate in the home environment, because the capabilities of our robotic systems and the form factor that we wanted with robotics, it was going to still not work that the way it needed to really do interventions. And so thinking about how do you provide a intervention scenario, a gamified scenario with these robotic systems, we quickly converted to the way that we do it is we capitalize on the interface. So we capitalize on the games that are in virtual reality, whether it's in terms of virtual reality, i.e. remote operation, or it's in tablet-based games or those kind of games that are much more closer. And what that allows us to do is therefore it puts the robot as a partner, as a playmate, as that human engager, substituting the human engager. And our intervention is actually then encoded in the computing platform, which does not require us to think about actuation and the failures of actuating in the real space. And so by decoupling the intervention and the therapy from the robotic platform, it allows us to, one, be creative in terms of our interventions, but also be creative in terms of our robotic behaviors and engagements. And so that process of thinking about engineering and thinking about how do you decouple the things that are hard, that are still fundamental research that we still haven't solved, from applying it into the real world, is a skill set that we as educators should be teaching our students to think about this, that the solution doesn't all have to reside in this one kind of gadget or this one type of robotic system, that the solution may take advantages of things that are out there and couple it with the gadget that we have. And so our robotic strategies involve casting our robots as a playmate. And even though, I started off as a robotics doing manipulation, my robots do not manipulate, they move. They simulate movement in the space in terms of arm movements, but they themselves do not manipulate physical objects. The child manipulates their hands to interact with virtual objects. The robot manipulates its hands to also interact with virtual objects. And therefore, we took away some of the difficult problems of physically interacting with objects in the space away from that. And so I can go into, and I'm not going to go into kind of the movement profiles, the way that we think about, what is optimal control for a robot in a manufacturing industrial environment versus optimal control for a robot that plays with kids with special needs. To tell you the truth, when we think about optimization, they are different because the parameters are not just about accuracy or energy efficiency. The parameters that we have to incorporate are also about the fact that you have a human that is noisy, that has behaviors that are not well modeled, and that can change and adjust at any moment in time. And so thinking about our control also requires us to rethink how we design these robotic algorithms in terms of the movements and how they interact. And what I'm going to show you and then kind of talk about where this is. So I always like data. I like showing data. I like showing the results. And in this aspect, what I'm showing is one of my favorite subjects, participant studies, only because it allows me to state something about engineers and our technology when we're interacting with people. So this was one of our early one of our early studies. So all of our studies involve a robot, this gamified system, coming into the home environment with the child in their natural space. And the robot acts as a playmate where the child interacts with the game, the robot interacts with the game, and the robot also interacts with the child in terms of both motivation and things like that. So this one, what we wanted to see was, is the robot effective, right? So how is the robot doing what is the impact? Does the child improve in terms of the kinematic metrics and things like that? And what we wanted to do was look at the differences between children with, in this case, children with cerebral palsy and children who were not diagnosed with CP, so typical movement in terms of the kids. So we did this, and why I like to show this study is that we had a variation of the type of abilities for the child in terms of their movements. We had a range of ages as well, and we tried to correlate with respect to gender. So we had a mixed gender in terms of equal numbers of boys and girls in the study. And if I look at the data itself, one of the nice things is I always say robots work, and we always claim that as a roboticist that robots work, but showing the data to show that it actually works it always makes me happy. And so just to show you, this is round one. Round one was just with the game, where the child was interacting with the game based on their own abilities, no guidance except for this is how you play the game. Then we would introduce the robot into the scenario. And this one, what we wanted to do, what I'm showing you here, is we wanted the child to move at a faster pace. And so this was improving their movement profile. We also tried to improve range of motions and other metrics that are used in the clinical space, but this one is about moving faster. And what we found was that when the robot was there, the children did move faster. So the graph on the bottom is children with CP. The graph on the top is typically developing children. And when the robot was there, children on average moved faster with some variation. And one of the things about this was, how do you define faster against a generalized norm? And so the way we thought about this was we would figure out what faster was based on the child's baseline behavior. And so every child therefore improves. And then when we took away the robot, what we saw was typical kids maintain some of the same profile, but children with CP actually dropped. They didn't go all the way back to their baseline, but they were not with the same, they did not move at the same speed or the range of motion when the robot was present, which really showed some of the power of robotic system, as in when the robot was there, the robot was actually an attribute. It was an asset to this intervention because it actually made a difference. And it made a difference in a way that, and later on, we had other studies where we showed that this change continued and lasted even when the robot eventually disappeared. And it actually takes a while for that to happen. But it meant that as engineers, we could design robotic systems that actually worked in terms of improving someone's quality of life. And this was not a toy problem. These were real kids. These were real kids in their homes with real parents and real clinicians and therapists. And the robot was able to make a difference in a child's life. And so that power, I will tell you, is what we provide being in engineering, being in computer science, is the ability to change minds and change lives. And so when I think about what this means in terms of research, so this is my system, the therapy, the robotic systems. But one of the things that we can do as academics, and one of the things that we can do in terms of the future, is as we're designing these technologies and we're doing this basic research, thinking about what is our role in order to impact society in different ways. One of the ways that my group has done it is commercialized a lot of these methods, a lot of these technologies, a lot of these intelligence tools, and put it into products that could be deployed and used in the home without a scientist or a researcher coming into the home and setting up the experiment by itself. And so that translation is just one way that we can enable the things that we do in our lab to have an impact in the world and in society, is thinking about, as we're deploying, as we're working with these domain experts, what is the next step in terms of getting it out into the real world so that people can use it outside of our own lab environment. And that's translation to the industry. And why I say that and why that is of value, the fact is that in the world of AI, that has actually happened. If you think about all the things that are going on in the future of artificial intelligence, what has happened is that the things that were just in the lab, that were just on someone's laptop as a grad student, in literally a very short amount of time, and I say short in terms of an academic lifetime, those research toy problems have turned into actual applications that are being used by companies in real world scenarios. And there wasn't a transition of taking the lab research and, let's figure it out and let's do little pilot studies. It's been, oh, that actually works. That GAN actually works for this. We're just going to deploy it. And if, as you all know, when we design things in the lab, we don't necessarily design them thinking that a billion people are going to use it. So I'm going to talk a little bit about what this means in terms of the future. So this talk has changed a little bit because of COVID. And one of the reasons is that, before COVID, before the pandemic, as a person who works in this robotics and AI space, the kinds of applications that were out there were nice. They were helpful, but they weren't as, I would say, impactful to the general public. And so you would have things that were negative, such as facial recognition and surveillance, but you didn't necessarily have facial recognition for healthcare or for doing things in mental health. But what has happened is, because of our need for removal and social distancing during COVID and pandemic, what we've seen is an acceleration of the use of these tools in the world. And because there wasn't a preparation, it wasn't like, oh, in 2 or 3 years, that algorithm that you designed in the lab will be used. It was oh my gosh, we need something tomorrow. What does anyone have? Can we get something out in a month? And so a lot of things are now out there that are being deployed, from healthcare diagnosis to delivery to medication adherence to chatbots for health and diagnosing mental and depression. And all of these were not done with all the due diligence that is we typically think about when you release a product into society. And so as a person who does AI and robotics, it's like, oh my gosh, like it actually means that all these things are actually out there. And you're like, oh yeah, I know what this is about. I know how this operates. But it also means that there are things that aren't as ideal or optimal as they can be. So giving you a feel for some of these areas that have come, they've accelerated, and they're continuing to grow. So one is in this space of AI and wearables. And so I mentioned, if you think about IoT and all these things that are out there embedded in our environments, embedded in our clothes, embedded on our bodies, in our city streets, all of this data, it means that we are starting to see a lot more use of AI and wearables. And when I say wearables, it's things that are on, in, and outside of body, that are being used in mostly positive ways in terms of workforce productivity, as well as health attributes, and making health a little more personalized, because now I have data that's about me and me alone that can then be used to do things such as, is my medication dosage correct? Am I looking at the right things when I do this? In my own group, we do wearables for infants to do early diagnosis of preemies that potentially may develop a disability by looking at their kicking patterns. But this is just one application of using the power of devices and sensors coupled with artificial intelligence to really make an impact and expand the ability of doing something useful with all of this data that we're doing. And again, it's accelerated, it's gone, and it's continued. And one of the kind of future things is that, because a lot of these tools are starting to be linked with health, we have organizations such as the FDA that are also starting to get involved in looking at data that's related to health. How do we actually regulate it? If you have a health-based application that's using AI, what are the regulations in terms of the class and how many subjects you had to test, and do you have to go through clinical trials? And so we're seeing a lot of movement in this space here in the United States. It's FDA, in Europe as well, about the use of this data and the use of artificial intelligence around specifically health, because that is typically considered something that is protected, which is, again, implies that as researchers, any researcher that is in this space of healthcare, that's in the space of artificial intelligence, since a lot of these algorithms were literally plucked from the lab and deployed, it means that we are going to have to start to think about what are these ramifications from the research stage, from our very first study where we design a sensor and we're collecting human subject data. We are going to have to start thinking about what are the ramifications when, not if, but when this gets deployed into a product by some company that read our paper and said, this is a great idea. We are now going to take this algorithm and deploy it into our sensors and our products. And we're seeing, again, that acceleration. So as a researcher, that's great. It means our stuff is being used, but it also means that we need to take a little bit more care, especially in our research group and with our students, about thinking through the possible negative ramifications, the equity issues in terms of how we're designing these algorithms and thinking about that from the very beginning. The other area that I'm seeing an accelerated use in terms of the future of AI and education primarily and workforce development is the use of AI data and simulation. So a lot of times in the past, for those who worked on educational tutors, there was always a lot of buzz about personalized tutoring and these tutors that could be adaptive and customized to you. And what we've seen is things like, testing will adapt. So if you're taking an exam, SAT, GMAT, it adapts to your, if I answer this question at this difficulty level, the next question is going to be based on that. And so there has been some personalization in some of the testing, but in terms of a learning space where as a student, I'm working on a problem, maybe I'm stuck, maybe I need to figure it out. How do you design AI to augment the abilities of a tutor, whether it's a human or an AI tutor with this data? And so, we have some great, I always like to talk about Shook Gold's work in terms of designing these tutors that can provide information and scaffold our educational system based on the data that's extracted. If you think about when you're teaching a course, you can probably figure out how many times you're going to get that question A every semester about that same assignment over and over and over again. And you repeat it, and sometimes you actually save your answers from the semester before and you cut and paste because you know that you are going to be asked this question. So imagine that this can be automated based on that data, and even the system can identify when you have a student that answers a question in a certain way, then oh, in terms of their knowledge base, they're missing this fundamental concept because we've tracked it and we know this from previous semesters and previous data. And so that is really the power that we're seeing in terms of not just in our space, the education space, but also in this workforce development space, because as AI becomes much more prevalent, as robotics becomes much more prevalent, what is happening is that there is changes in the workforce and the skills that are needed in the workforce. The jobs that are being hired for today, as you know, are not going to be the jobs necessarily even 10 years from now. There will be a lot more different jobs, but there will be a lot of jobs that will disappear. And so how can we do this retraining of the workforce of our students after they graduate such that they still can maintain their skill set? And so in the video, what I'm showing is some training tools we had for resident students in terms of learning new robotic surgery tools as they're doing the training without actually training on a real human body. And so ideally, what this would allow you to do is have the same type of haptic sensation as if you're operating on a body, but not necessarily do it on a body. And we also, again, collect data from individuals in terms of teachers, clinicians, working with children and collecting that data about how learning is done and things. And so this is another area of growth, also is being accelerated again within the last year, definitely, but also with the fear that our jobs are going to disappear. And therefore, how can we supplement this fact that there will be a lot of individuals that will not have the ability to keep the current jobs that they have because they will change in that aspect. So two other areas that are growing in terms of the future is collaboration. So this is collaboration between humans and robotic AI systems. And so one of the things, and there's been a lot of studies that have shown, when you have humans and machines working together and you do it strategically. So it's not just, designing a robot and just putting it in, or designing an AI system and just adding it to the human's workflow. But it's really thinking about the job as, what are the strengths of the human? What are the strengths of the AI system? And then redefining and redesigning the task such that it takes advantage of both of those skill sets. What research has shown time and time again is that you have an optimality in terms of outcomes of the job function. You also ensure that the human is much more productive and quote unquote happy as well. And so this element of collaborative robotics, one, it also links to training and workforce development. So a number of promising research that's out there is, imagine you have a new job, you have a worker who's smart but doesn't know the job functions. How do you then bring in an AI agent that walks them through where they're doing this a collaborative task, and little by little releases their expertise in terms of the AI system, so that as the human progresses, the human gets better, the human is doing more and more and maximizing their potential. And then when there's another task, recognizing that the human is not doing well, AI system then gets accelerated in terms of the amount of work it does, and then continues. And imagine that you had this partner, this AI robotic partner, for your entire career life, from the time you graduate from college all the way until you retire, that understands your nuances, understands your behaviors, and understands all these things in terms of your skill set, and can learn and adapt to you. And so that is one of the things in terms of the future. And there's some promising research that shows that this can actually be done. Not in real time though, but it can be done with enough data and with enough understanding of the human and the job function and the capabilities of the AI robotic agent. And the last thing I want to talk about in terms of the future, and then I'm going to talk about some of the negatives that I worry about, is what I call emotional artificial intelligence, emotional robotics. One of the things, as we don't really consider always as engineers, that as humans and as people in society, they have emotions, right? Emotions actually drive a lot of behaviors. We've especially seen this in the last year, whereas, logical sequence of steps, A, B, C, and D, not all humans understand that logical sequence, and a lot of them are driven by emotions. And so when we're designing our systems, when we're designing this future of AI, even now into the future, understanding that emotions is part of the equations. It's not a separate attribute, it's actually part of the equation, because humans will operate and interact based on their emotional state. And so there's a whole area of emotional AI, which used to be thought of as a secondary thing, like, oh yeah, we have emotions on these AI systems, we should understand humans, but it's a secondary, it's a nice to have, not a necessity. But we're now seeing that it becomes a necessity. It's actually a competitive advantage for companies that understand the emotional state of their user as they're using a product. And so this is being a field that has accelerated. It's one of the reasons why, for facial recognition, as you know, most companies have adopted this. As you know, there was a little bit of pushback last year about facial recognition software, specifically being used in surveillance and policing, but in general being used at all. And one of the reasons is that companies have accelerated the use of using facial recognition to understand our emotions, to do everything from marketing. So if I can understand your emotional state for marketing and advertisement, I can also influence your shopping behaviors, which is good for companies in terms of their bottom line, to, of course, more of the negative things that impact our civil liberties, such as policing and surveillance. And so facial recognition that's linked to emotion AI has accelerated in terms of its use. It's also the one thing where regulations and the consideration of regulations around this space has also accelerated. Everything from the EU just released some information that targets emotion facial recognition, to some things that are being considered as bills in DC, as well as some of the local cities and states have already implemented regulations around the use of emotional AI and facial recognition. So this is one area that if you're into artificial intelligence, it's one to definitely watch, but it's also one that we have to understand because it will be embedded in the things that are coming out in terms of products that are being used by and with people. So we know that with the use of AI, the use of robotics, it improves our quality of life around all the things that we're interested in: healthcare, education, sustainability, in all these aspects. And we also know that people generally trust the use of these. And we can go a deep dive of what I mean by trust, have a whole area of research. But I want to really talk about some of the problems and some of the things that we need to think about as we think about the future of AI, as we think about the future of AI coupled with our fundamental research and things like that, is that because, as I mentioned at the beginning, we have these sensors, we have these devices, we have the collection of all this data, and the data is based on us as people. And we as people, we have our own biases, we have our own nuances. And therefore, when these systems are being designed and developed, they are also inheriting some of our own unique biases. And bias by itself is actually a survival mechanism. But bias, when we are looking at it from a societal point of view, actually has negative implications on a number of different fronts that are apparent. And one of the problems, therefore, is that as we're designing these systems, because they are being designed based on the biases of society, the biases of our own individual human behaviors, they're also being designed with the biases of the creators, which are our students that we've graduated that are now in the workforce. And so the question then becomes, how do we counter that we have the sources of uncertainty, inaccurate data based on these biases from our use of technology and our interactions with others? And we have the biases of the individuals, us as engineers, designing these products. And so you have these two sources, these two tranches of biases that are both being integrated. And so identifying how to design products and solutions to deal with this is one of these aspects that are difficult to do. And so what I want to talk about is, I'm trying to figure out what's going on. So one of the things that we think about in terms of the biases that come into both our societal biases as well as creative biases are inherent. So there's been some research, for example, that's shown that I have a bias as an individual, and this is, everyone has these biases. So it's not that you have a bias because of this attribute. It's that every single person, if you are a human living on Earth, has a bias. And so we have biases. They're called in-group versus out-group. There's biases with respect to gender because I self-identify as female, and so I understand what it is to have a lived experience as a female. And so when I look at the world and when I look at problems and when I design solutions, I'm looking at it from that learned experience. In terms of age bias, if I'm 80 versus I'm 30, I'm going to look at the world and look at the solutions and design my solutions based on the experience of either a 30-year-old, which lives in this time of technology, or an 80-year-old that did not. And so these are what make us unique and special, but it also is what is being embedded in our applications and our products and our devices, and also in our teaching, frankly, of how we teach but from how we were taught is typically how we then teach, which also means that any biases that were present as we were taught are also being propagated through the way that we teach, and it continues and continues and continues. And so thinking about this and thinking about what does this mean, because there are biases in the data, because there are biases in the designers, because there are biases in society in general, it also means that there are outcomes in our products, in our decisions. That means that there are differences in what our systems do and design. We have seen this over and over again in terms of healthcare diagnosis with respect to gender, across race and ethnicity, and across age, because we typically don't have 90-year-olds that are designing the codes and the algorithms for their healthcare, because typically they are retired, and yet these systems for health diagnosis are being used and abused to then make decisions about 90-year-olds. And so we know for a fact that the outcomes can be slightly different. And one of the things we can do as educators is ensure that as we're teaching our students, as we're designing our curriculum, as we're doing our research, to being aware that there are going to be biases, and basically saying, we know that there's going to be biases. Are the ways that we can retrofit and think about this? Because if we don't, I have a fear that as engineers, we are going to start being the bad people. In fact, if you see a lot of the news, and this started, I would say, probably about 3 years ago, and every day I can literally find a news article that talks about algorithms and AI in a negative light, and people see this. And so this whole aspect of artificial intelligence and robotics and the negative ramifications and the unfairness continues to come out. Everything from, we can call it fake news. We now have, fake voices. We have fake text. We have fake news articles. We then also have these aspects of, chat bots that could potentially drive someone to suicide. All of these are products that are being used in society that literally came from someone's lab algorithm paper that was then deployed without thinking about the aspect that there are issues from the beginning. And so I always think that as researchers in this space, we should be thinking about the biases in our products, in our devices, in our research from day zero, because it's not when my information, when my algorithm gets used in a product, it's basically that it's going to be, and it's probably going to be before people realize. And the companies are not necessarily going to be thinking about the bias that's present. And if we're not thinking about it from day zero, it is going to be present when these products go out and are being used by people. And in fact, if you even look at some surveys with respect to general audience about how they feel, most individuals say that they don't think that these systems can be fair. They will use them. They think that they could do the job, but they do not think that they can be fair. And if you look at specific items of, well, if you were going to have an AI system, should you use an AI system for, say, policing? Most people say it's unacceptable, and yet we have these systems that are out and being deployed. If you ask, well, should you use AI system for automatically screening resumes for job applications? A lot of people, majority would say, no, I don't think so, because it has some negative consequences and not fair. And yet we know most companies use AI to do screening of applications. And even in the higher education space, we're starting to do that as well. And so if you think about all these things that people are saying, it's unfair and it's unacceptable. The fact is that these things are already out there being used, being deployed with all of this aspect of unfairness, bias that's embedded. And this is where we are now. And I think we as researchers can actually do something about this, and we can turn the clock back a little by thinking about it in our own fundamental, basic, or applied research. So I think there is hope. I think that we can get ahead of this, even though it's accelerated. It has not gotten to the point that it's fully ingrained in everything. And so I think there is hope as academics to really start thinking about how we do research with our students, really start thinking about teaching the ethics within the very beginning when we're working with students, so that when our things are deployed in the commercial space, in products that are used for society, it's thought of in that aspect. And one little point that I'd like to bring up, and then I'm going to open it for question, is that this is actually a thing. This is actually a field, this whole field of algorithm fairness. I actually wish that we would adopt it more in engineering. So a lot of the work in AI fairness, AI bias is primarily situated in some cases, computer science, but in other cases in the non-necessarily STEM fields, which I worry about because as engineering, we do ethics, but we don't think about necessarily ethics within the curriculum, embedded within the curriculum, embedded within the courses we teach, within all of our senior design courses, capstone, and all of these things. And so algorithmic fairness, it is a field, and we don't have enough engineers that are adopting it, which means that non-engineers are going to start designing the solutions for us, which, as you know, may or may not work with our technologies, with our products, because they are not necessarily on the inside of how things are done. But it is a field, and I encourage you to look into it with respect to your own departments, your own units, and within your own research. So lastly, I think that we need to focus on people, focus on our students, focus on giving them the tools in order to address this future of AI, giving them the tools to address this future of ensuring our products are used in a fair and ethical way as they're being deployed, as they're going out. And I think we also need to focus on the aspect of there is a diversity of people that are out there. There's a diversity of biases. And given that we all program and design and teach from our own lived experiences, which means we all do this from our own biases, that we need to ensure that we are bringing in multiple voices into the equation to really design and develop this future technology that is being used by all of society. And so with that, I think it is our responsibility. It is really no one else's responsibility except us, because we are the gatekeepers of the future. We are the gatekeepers of future in terms of fundamental research. We are the gatekeepers in terms of the future of the workforce. And therefore, as gatekeepers, if we don't lean into this and we don't lean into thinking about our responsibility in this space, honestly, I don't think anyone else will. And if they do, they won't solve it the way that we can. And so with that, I want to say thank you, and I will open it up for a few questions. Thank you.
All right. I'm ordained as the moderator for this question session, and I think that I'm going to serve very little purpose other than to call people's names. Here's my suggestion. If you have a question, just enter into the chat to everyone the word question, and then I will call on the people who are there roughly in the order that they appear, and we'll ask you to unmute yourself and ask your question. If you're not comfortable unmuting yourself and asking your question, feel free to type it into the chat, and I'll be happy to direct it to Dean Howard. And I know, because I've known her for a long time, that she's perfectly capable of reading, but I want her to be free to think about the questions without having to watch the chat as questions roll in. So if you have questions, that's the procedure. And while you think of how to begin your questions, I'll start. First, I'm going to say I'm delighted when you became dean at Ohio State. I thought I would never see you again. And only a few weeks later, here we are in the virtual world. I'm delighted by that. But I'm equally saddened by the fact that you now self-identify as an engineer instead of a computer scientist, and that's hard for me. Here's my question. In AI, AI is ubiquitous. It's making decisions for me all the time. And therefore, if AI goes wrong, there's real consequence in the world. Robots, it's much less so. I'm a roboticist, and it's literally been a couple of weeks since the last time I even saw a robot. They're not out in the world in nearly the same way that AI systems are. And I wonder if you have any idea when the heat will come to the robotics community, and if you have any predictions about what are the things that we're overlooking now because we're not as ubiquitous and we just haven't noticed yet the kinds of things that are important.
Yeah, so with robotics pure, so I always consider myself a roboticist slash AI person because I use AI methods in my robots. And one of the things that I worry about in terms of pure robotics is that we're not even talking about this. And so there's examples. So there are, robots, and in fact, Boston. So as you know, the Spot was used in New York recently, in a place where people were like, why did you use Spot in city streets to go into a home in that case? Now, a human was operating, kind of in control, but it's not that far removed to think about the fact that now that robot could be autonomous. And there is,
Yes, let me ask Kyriaki Kalietchidu to mute yourself if you don't mind.
and so, I mean, this is a fact, right? And as a roboticist, we're not even having the conversation of, an AI system, there's still some human aspect. When you then have a robot that is doing something, they are doing something, right? They are applying force, they are pulling the trigger, they are dropping bombs, they are doing these things, and there's no necessarily human in the loop that can say, oh, the AI told me this, and therefore I'm making a decision. And yet, as roboticists, we are not talking about this enough. And what is going to happen, because this is what happened in the AI world, there's going to be a switch. And all of a sudden, we're going to be like, how did that happen? How did all these robotics suddenly become deployed? Like, how did I miss this? And we're not talking about this at all. I do worry about that because, as you said, robots apply force. Once you kill someone with a robot, you can't reverse it. Whereas with an AI system, once you make a mistake in facial recognition, you can go back. It's like, oh, sorry, you're in jail. We'll take you back out of jail because there was a human that used that information to make a decision.
All right, there's a question now in the chat, and it's appropriate for you as a dean because it's a curriculum-related question. Basically, there are so many prerequisite skills and associated courses and credits to master the engineering field. Would it be a big burden, to reduce that somehow? I think is the essence of the question.
Yeah, so I have a philosophy about this. In engineering, we do have way too many prereqs that seem like it's required, right? And so there are some fundamental skills that all students should have in computer science and engineering. That is guaranteed. But the fundamental skills are not necessarily, so electrical engineering, fundamental skills is or is not circuits and control. What happens if you are in a different field where your computer architecture, do you really need to have control, like fundamental knowledge, deep knowledge of control? And so I think that as engineers, we need to revise our curriculum. And it's because we are so in love with how we were trained that, of course, we can't remove it because I'm a great engineer, and therefore my students, to be great engineers, have to have exactly what I learned. But yet the field has changed for the last 50 years. And so now they also have to learn all the new knowledge of the next 50 years. And I'm hoping that as units, as departments, as colleges, we will start looking at this, because a little known secret is the students, they're starting to survey the high school students. They've been doing this over the last 5 to 6 years, and students are losing interest in engineering, which surprises me. They're gaining interest in computer science, by the way, but they're losing interest in engineering, which basically means if we keep down this path, in another 10, 15, 20 years, we will be like, we can't do research because we can't find any students. And we have all these faculty with 2 students. And so department chairs will not be able to hire because it will not be a degree of choice anymore, is what will happen.
The next question, actually, I think is quite related to the last part of your answer to that question. First, the compliments. Nice talk with your research and also translation practice in the HCI area and increased interest in our research having impact. Then, what are the challenges you're going to address as the Dean of OSU to reflect and change the system so we can have impact?
Yes, I'm actually excited. So one of the things that Ohio State provides is scale. So there's a couple of things that have been announced. One is increasing our student population to 8,000 new STEM graduates. And so this is something about scale. Some of the things that we are thinking about is how do you enable anyone who remotely wants to do engineering? How do you enable them to have the skills to think like an engineering mindset, without necessarily taking thermodynamics and controls and CS 1, 2, 3 and whatever else is the flavor of the year. And so we are actually starting these conversations of what is the fundamental skills. So there's a difference between a skill and a knowledge. So what are the fundamental skills that we need in our engineering students versus knowledge? And they're two different things. And so we're actually starting this process of thinking about this, skills versus knowledge. And what does this mean? Because Ohio State, we have such a large scale, we are then hopefully going to influence our sister schools, such as Georgia Tech, to figure out together how can we then disseminate this, because engineering, and just so you know, Seth, computer science is in the College of Engineering. So I actually have a joint position in computer science and electrical. And so computer scientists are engineers in my college. But how do we then influence the field to think differently about engineering education?
So, Seth, can I just follow up with one
Please.
question? So, ethics is a big part if we are thinking about AI, but ethics is not a big part of curriculum in engineering, at least what I've seen. And this is not something you can teach in one course or two courses. This is like entrepreneurship you want to instill in a student. That's how I probably see ethics to be instilled as a skill. It's a way of thinking. And how do you get that just through classes? That's
Yeah, so this is part of some of the things we're thinking about. So I think one of the low-hanging fruit ways that we can do this is rethinking how we do something as simple as our exercises and projects. So if you think about, I'm going to try to teach feedback control, right? And typically, think about the classic problem. There's like the classic problems where you have your input vector and your feedback control loop, and it's in this vaporware. And so imagine instead you say, look, we want to build a well in sub-Saharan Africa. The water source is 3 miles away. All we can do, and we have this walking pattern, and the soil composition is such that, right? And then lay out these parameters such that they are equal to, at the end of the day, you're going to create a feedback control loop, but you're basing it on a real world problem. And so you have to think about your choices, and you have to think about when you're designing and thinking about your parameters. It's not just your parameters to make your system go down to zero, because maybe you don't want it to go down to zero, because if you did, a whole village would be dead, right? And so having students think through, have knowledge, but base it on having to make these decisions in order to solve a solution. I think one, it gives them some understanding of the value of engineering to society. It also makes them have to think about their choices, that in these ethical choices, but within a safe space, so that, I need my grade, it's a safe space. And eventually, by the time they become seniors, it just becomes inherent in their DNA that they will ask these type of questions. We don't know if it'll work. It's an experiment of something that we're dribbling and going to try.
All right. You can really see, I can really see, I guess, emerging in the chat. I don't want to say attention, but there's the sort of engineering demands versus the ethics demands and the societal pull, all in different directions. And the next question is, what can universities do to encourage emotionally intelligent students to become AI creators?
So one of the, and this is a study that came out that showed that when high schoolers first come to college, and this is our current batch of students, when they first come to college, they are, they're 17, 18, 19-year-olds, but they are much more connected in terms of their responsibility. And I won't say emotionally intelligent, but they understand their social responsibility. They understand, they have a passion for something. So that emotional, connection to the world and their place in that world. And the studies have shown that after their 4 years in being in engineering, their primary concern is not, passion for something, changing the world, connected to society. Their one passion is getting a very, very, very good job, right? That passion of, changing the world, doing good, it actually drops down quite a bit. And so what that means is that it's the university that is doing something to change the student perspective. And there's there's the competition, there's the fear of grades, and we actually find that at higher ranks, so R1s, this change is actually more drastic than some of the other ones, R2s, and you can probably guess why. And so I think at the university, one of the things that we can think about to encourage, and really it's basically to make sure that we keep the road and basically keep those passions, is to, as I mentioned before, rethink how we're doing the curriculum, rethink how we're bringing in societal problems into the engineering classroom, not making, outreach. It's like, oh, you're doing outreach. How can we bring in outreach so that it becomes part of, a design project? If you are a student and you want to do a project in the community, as part of your learning process, we should be enabling that much more seamlessly than it being an exception. And so that's us as educators that have to do that. And it's not easy. Like I'm saying, like it's, we can turn the switch and we do this tomorrow, because personally, I know this is sort of counter to our culture. Honestly, it's not how we've been taught. It's typically not how we teach. And so it does require a change in our culture and in our understanding of what is of value in engineering. But I think we can do it. And if we can't, someone is going to do it for us.
All right. Next question in the chat. Thanks for a great talk, Ayanna. I'm interested in how your work can be used to train or perfect experts. Can robots help Giannis shoot free throws better? And I'm assuming you know who Giannis is.
I'm looking for. So how do we use robots to
train or perfect expertise? For example, in physical activity. Professor Mazumdar is here. It's his question. I'm going to let him clarify.
Okay.
I was trying to think of, I thought your work's super cool, and I know you focused on children who are experts at certain things, but I was wondering how some of these technologies could also be used to, train some of the peak performers, whether they're athletes or actors or dancers. And I used a basketball joke because it made sense in my head, but clearly it fell flat.
I got it now. I got it. So yeah, I mean, the skill set of the individual actually doesn't matter. So one of the things in our methodology is that we identify the baseline of every child, right? So that baseline, it could be, peak performer. That baseline could be a child who has a very severe disability. We've also worked with stroke recovery patients as well. And so that baseline right now, even in our methods, it's adjustable because it's personalized to the individual. So if you have a peak performer and you want them to increase their, swing style, or you want them to increase their batting average, and what that requires is that they have to learn how to swing faster, for example, the system that we have would actually work perfectly. The only difference is what are we trying to measure, right? So in my work, we're measuring some very specific things based on the kinematic measures that the clinician has identified. And so that would be the only thing is what are those metrics that we want to improve on, and put those in the system, and it'll actually work quite well.
Cool. Well, it's always good to see you again, so thanks.
All right, another question in the chat. Thank you for a very interesting presentation, Dean Howard. I think you made a very interesting point about how we have to take the lead in creating ethical, socially responsible tech. I was wondering what your opinions are on technological stewardship in fields like this that require a lot of data and oftentimes from multiple sources. How do we decide who should be evaluating or monitoring AI ethics standards, especially since we see it emerging in myriad fields? And hopefully my question is not too far out of scope, and I will declare that it is not too far out of scope.
Yeah, it is not too far out of scope. I will tell you, this whole conversation about AI ethics is a conversation that's going on now. And everyone and no one is claiming it. We have government that is trying to come up with standards and policies. We have nonprofits that are trying to come up with policies and standards. We have watch groups. We have academics. We have companies, in fact, that are trying to come up. I will tell you right now, this field of who owns what it's the wild, wild west. There is no one champion. And not all the voices are at the table either, which is one of the things that I do worry about. And what this means is if you're interested in it, there is actually room for more voices in this space. The thing I worry about the most is that our governments, whether it's the US, whether it's the EU, whether it's Japan or China, my biggest worry is that governments will control the messaging on the regulations on AI ethics. And I think in order for that not to happen, I think as academics, as nonprofits, as civil liberties group, we need to start thinking a little more strategically about setting policies and best practices, especially with respect to companies, so that government does not have to. Right now, government feels like they have to because we have a lot of bad players that aren't being ethical and are not behaving ethical with their technology. It's actually my greatest fear right now.
So let me just follow up, Seth.
Okay, go ahead, Dennis.
Yeah, so I was because there's something I've thought a lot recently. There are a lot of unintended consequences with these kind of technology. And if government don't take the ownership, we have seen from the privacy laws from Facebook and other that if a business is only driving the conversation about rules, it's going to be very challenging in different countries. You don't have a standard which is all across countries same. So shouldn't this be driven by maybe a new organization to think about, which looks at these standards across different countries?
So it would be lovely if we had something like, a UN of responsible technology. That would help because so think about an organization like a UN. It's not really government, right? But government feeds into it, right? Nonprofits feed into it. Other agencies feed into it. And everyone pretty much, respects it and respects the things that come out of it. The only thing that's really talked about at that level is basically robots that are war kind of robots, weaponized robots is really the only real conversation that's happening at that level, which again is not the conversation I think is the most important necessarily. But I would love if we can figure out how to get organization like the UN to really think about this as one of their goals and bringing in stakeholders from the different places to think about this.
So I think of that as a human rights issue, because when I look at autonomous system and if they don't recognize in the site a person of color, that's a human right issues for me. So shouldn't the UN human right bodies should combine thinking about with different companies? You need companies there because at the end of the day, they have to implement those technologies.
Yeah, no, that's a great idea. And it's not necessarily happening right now.
Yeah.
So as universities, the academy, we have some limited influence on how governments operate. But we have a much more significant interaction with industry. We send our students. So as the industry exist because at some point somebody in the academy taught those students how to do that stuff, and they depend on us for the next round. What do you think is our role? Because as much as governments are trying to regulate, large tech companies are trying equally hard to establish the boundaries of this playing field. A large company, for example, has an AI group that gets a little too ethical, so they fire a couple of people that run that group and then try to gaslight the community about what really went down. In a hypothetical situation like that, what do you think is the university's role, or do we have one?
So I actually think the university could act as a third-party auditor, honestly. I think that, as academics, we have no we have no boss, we have no real supervisor, right? We will take funding from a company and then say that their product sucks, right? Because that's what we do. That's the whole academic freedom aspect. And research is research. If the data says this, we're not going to say, well, because you funded me, I'm not. No, it's like, well, then we'll find someone else to fund us. So I actually think that universities could function as third-party auditors. The challenge, though, is we typically don't cast it as a research problem. So we don't, as academics, we don't typically provide service roles for others. And so how could we think about this as a research problem, or how do we think of it as something that's under what we would traditionally do as an academic or as a university, would be the challenge. But I think third-party auditor would fit us nicely in this realm.
And Devesh has left a comment that the university needs to be an honest broker.
Exactly.
So I know it's 4:44, and I know you have another meeting coming in, but thank you very much. Thank you, Seth, for moderating the session. This was really exciting. And I think it's an exciting time for AI because we're going to be seeing a lot of things in this area moving forward in AI, whether it's in a space for work. We are looking at this in the education. We're also looking at how do we help people to improve human conditions. So there's going to be a lot of conversation about unintended consequences.
Exactly. Thank you. Thank you. Have a great one.
You too. Take care and thank you, everyone.